All right, here's how to do some practice problems with scientific notation. So the first three we're going to do is expand the problem, and the other one, expand the problem into scientific notation. So let's start with that first. Let's say I gave you the number 67. I want you to put it into scientific notation. Here's how you would do it, okay? Here's the original number. Here's what's going to be a scientific notation. Make it nice and easy. All you do is you start with this number, so 67. You're going to write down the 6, the first number first, then a decimal immediately, and then everything after it. So it's going to be a 7 afterwards, right? Then you're going to put times 10. And here's the thing that matters most. The question is, how many times, if the decimal was in the back here at the very end of the number, how many times did you move it left? Well, in this case, we only moved it left one time, or one space over, so it's times 10 to the first power. And that's it. That's scientific notation. Let's try another number. Let's try the number 387. So first we imagine that there is a decimal at the end. Then we're going to count. 1, 2. How many spaces did we go over? We went 1, 2 to the left. That's going to be our exponent for the times 10. And then we're going to write 3.87 times 10 to the second power is the scientific notation for 387. Let's try a bigger number. Let's try 49,673. How do I write that in scientific notation? Well, I start here at the back and I say, okay, how many times do I need to move my decimal over to be right behind the first number? That's going to be 1, that's going to be 2, that's going to be 3, that's going to be 4 times. We moved the decimal to the left 4 times. So that's going to be my times 10 to the 4th power. And my new number over here is the first number, then a decimal, then everything else. 9673 times 10 to the 4th power. All right, now let's go backwards. So let's say I know what the scientific notation is, and I want to go back to the original number. Here's how you would do that. So let's say the scientific notation is 8.2 times 10 to the 4th power. All right, what's the basic real number? Well, so what I do is I start off with the decimal, and I say, okay, it's right here, 8.2. The 4 is going to tell me how many spaces I need to go the opposite way, right? So I need to go 4 to the right. So let's do it. I'm going to move the decimal 4 places over. That's 1. That's 2, and I add a 0. That's 3. That's 4. I've now moved the decimal 4 places to the right. I can now rewrite my problem by erasing everything here. And what is the number left over? Well, it's 82000 with a decimal. And so that's the number 82,000 and 00, right? 82,000. That's how you write 8.2 times 10 to the 4th in your common form, okay? Let's try another number. Let's try let's try 6,290. Oh, no, sorry. Let's try 1.364 times 10 to the third power. All right, what do I start with? Well, first, I write down my original number, 1.364, and I need to write it in normal form, so I need to go 3 decimals to the right. So the decimal needs to move 3 spots to the right. Ready? 1, 2, 3. What's my new number? Add the zeros back here. It's going to be 1364 decimal 00. So my new number is 1,364. That's what 1.364 times 10 to the third is. Let's try one more. Let's go with 2.509 times 10 to the fifth. My first step is to rewrite my problem, 2509. Put my decimal where it was, then move it over to the right, 5. 1, 2, 3, 4, 5. Put the decimal at the end. Fill in the zeros and the empty spaces. Now let's clean this up a bit. Erase that original decimal. Leave the new decimal. Rewrite the number. The new number is 250900.00. Put my commas where they're supposed to be, and there it is, 250,900.